The next step of your data analysis after you have performed your data splitting is the exploratory data analysis. Here is where you investigate your data and prepare it for the primary analysis. The aims of the exploratory data analysis is to first get the maximum insight from your data to make the proper analysis plan. So let's say, for example, you're not sure if your data fits a regression type of problem, or does it fit a classification type of problem? Is the data time series, or are the variables categorical? So all of this can be answered while doing the exploratory data analysis. The exploratory data analysis also helps you investigate the underlying structures. So for example, is there a trend, specific trend in your data? If it's a categorical data, is every class, for example, outcome class, have a specific pattern in the covariates that are related to it? All of these underlying structures can be investigated and analyzed and concluded during your exploratory data analysis phase. It helps you understand the variables. So for example, knowing what type of variable is every part of your data or every part of your covariate pattern or the outcome variable, you would know that this variable, for example, is categorical, this variable is numerical, this variable is integer, this variable is double, and so on. And it helps you understand the relationship between the variables. So for example, understanding the correlation, if two variables are increasing with each other, or they are basically inversely proportional, so one is increasing and the other is decreasing, or are they completely unrelated? All of this helps you understand whether you want to get rid of some of the variables, whether you want to combine some of the variables, whether you want to perform additional variable extraction or variable dimension reduction techniques like the PCA. One of the also very important parts of the exploratory data analysis is detecting outliers, because outliers, basically data points that have completely different features than the rest of the data, will kind of ruin the model or make it biased towards a specific point that doesn't really represent the data. So detecting the outliers and getting rid of them is a part of the exploratory data analysis. Also, you need to detect the missing values. So for example, if you're talking about a data set with 1,000 or 100,000 or even more observations, some of the data points or some of the values for some of the covariates may be missing, and these can harm your analysis on whatever type of analysis you are doing. So you need to identify these missing values and decide what to do with them. Do I just remove them? Do I make them equal to 0? Depending on your specific problem. And of course, it helps you pre-test the assumptions. So many of the models we have learned in this channel and many of the machine learning models have assumptions. So for example, the LDA and the QDA, the linear discriminant analysis and the quadratic discriminant analysis, make an assumption that the feature vectors for every class is basically coming from a multivariate normal distribution. So such assumptions that can basically affect the performance of your model, or whether the model is suitable for the dataset or not, can be checked during the exploratory data analysis phase. And finally, it helps you understand the distribution of your data. So if you're going to look at your data without knowing anything about it, you cannot basically make a good assumption on what type of distribution does it fit. Is it bell-shaped? Is it basically account data that you can fit with a Poisson distribution model? Is it basically some data set that fits an exponential model like the waiting times or something like this? All of this can be found during your exploratory data analysis phase. Now to the approach of the exploratory data analysis. The first thing you need to know is that there is no standard fixed steps for exploratory data analysis. So it doesn't have like a guideline or a process that you first do this, the second you do this, third you do this. So what do we do? Basically what you need to do is do the reasonable checks to make sure that you are satisfying the aims that we have talked about in the previous slide. So you will generate the necessary plots, you will generate the necessary numerical summaries that can help you answer the questions that we have talked about in the previous slide. So what are some of the important plots and statistics that you do in your EDA or the exploratory data analysis? Some of the plots, first, if your data set have an outcome variable, you might want to check the distribution of that outcome variable with a histogram. So after you have split your data, now you have your training data set, you want to check how every class, for example, in your outcome variable is represented. is your sampling biased towards a certain class, so maybe you need to take another sample, or basically is the sample equally representing all the classes if it's a categorical classification problem. You need to check the histogram of the covariates to understand how the covariates are. Basically, are they normal? Are they different distribution type? You need to have a box plot of all the variables. This helps you see the range or the interquartile range, or where your data falls mostly for that specific covariate or outcome variable. You can do scatter plot between pairs. This will help you to see if some of the variables in your data are linearly correlated, so maybe they can affect you in multicollinearity or introduce some issues that you don't want. So seeing the relationship between two variables is important. Also, this helps you to make your analysis plan. So you see, for example, if your data set has 20 or 30 or even more variables, and you're not sure what type of regression you want to do, maybe once you start seeing the scatter plot between 2 or 3 variables, you will feel that maybe there is a relationship between this variable and the other two. Now let me investigate it with a regression model, for example. You do also the quantile to quantile plots, mainly to check the assumption. So for example, if you're assuming, or your method assumes that the data is coming from a normal distribution, for example, you might want to do a normal QQ plot. This helps you compare the distribution of your data to the theoretical distribution that you are intending to assume. Some of the statistics that you also need to worry about is basically the correlation between variables, because as we mentioned, if there is a high correlation between variables, some of the methods that you will fit might be affected. So for example, regression will be highly affected if your variables are correlated. It will introduce a problem called multicollinearity. You need to check some statistics about each variable, so understand the minimum, the maximum, as we mentioned, the IQR, the interquartile range, the standard deviation, the mean, the median. All of this helps you answer some of the assumptions. So for example, if you are doing a Poisson model, the Poisson model assumes that the mean and the standard deviation or the variance are equal, but in some of the cases they are not. So this is found during the investigation of the specific variable with these numerical summaries. Also, you want to check the counts of values for each variable, because your data set is very large, probably, or a big data problem. You are not sure if every variable has all the values for every observation. So you want to check. Maybe then you end up reducing your data set by taking a sample of 90% or 80%, then doing data splitting on that. So all of this is answered during your exploration of the data. Now let's go into an example in R, and we do it with RStudio to understand how you do exploratory analysis more. Okay, so if we go together to RStudio, basically I have prepared some nice script that will help us see how you explore your data. It works with a data set that many of you like, which is the FIFA 2021 players data set. The link to this, download this data set and follow with the code is available in the description, so go ahead and download it, and then let's continue with the code. Okay, so some of the libraries that we will be using. First, we will be using the dplyr library. It helps us a lot in manipulating data frame or data sets. We will be using a ggplot library, which helps us visualize things, as we have seen in earlier videos. We're using the readr library, which helps us read in the data into our script. We're using the ggalley, which also helps us. It's part of the ggplot kind of package. It helps us visualize some relationship between the different variables in our data. We're using library skimr. Skim is very important when you're exploring your data, and we will see why in a second. We're using library coreplot, which helps us see the correlation between the variables in a nice way. And we're using library reshape2, which is sometimes necessary to kind of manipulate a specific data frame to be an argument for some of the methods or graphs that we are using. So first, to load in the data, make sure that you are in the workspace by choosing the choose directory. I will be in that specific file where my data file is. Make sure that you are in the data file, and then read CSV, read underscore CSV, the file name. This now will load the dataset into your working environment, basically, as you can see over here. Now we can view how the dataset looks like. As you see here, the dataset has 106 total columns of different variables, and it has 18,944 observations. We're not going to work with all of this data. Let's say our problem is focusing on specific things. So we are using the pipe basically from the dplyr library to kind of select specific columns and put them in a new data frame. So we are using the data frame, we are doing the pipe, then selecting short name, nationality, age, height, and so on. So we're basically taking 12 features or 12 columns of our data set to be in our FIFA 21 data frame that we are using. Let's view how this data frame looks like. So it has 12 columns indeed, and it has the same number of observations. It has the short name, the nationality, the age, the height, the weight, the pace, the overall, the shooting, the passing, the dribbling, defending, and physique. So basically some features about every player, and it has all the players with their identification, basically the name, the nationality, the age, the height, and weight. So let's go into exploring our data set. First, we will use the skim function. The skim gives us the variable types, it gives us the number of missing values, it gives us the numerical summaries, it gives us the count, it gives us many important information that we can utilize to explore the data. You can do skim directly, or I like to do view skim because it gives me the results in a new tab. So let's do view skim of that specific data frame. And if you note here, it resulted in a data frame that has the variable name. Basically, if you remember, short name, nationality, age, those are our variables. It gives me the type. So now I know that the short name is a character, the nationality is a character, while the others are numeric variables. And it gives me the number of missing values, and missing. So I know that some of my variables, specifically pace, and some of the other variables over here are missing 2083 values. So we have 2083 players without values for pace, passing, shooting, dribbling, defending, and physique. And I can decide what to do with these NA values or not available values at later stages of the analysis. It gives me the completion rate, which is basically either 100%, or a proportion of that 100%. So here it tells me that 89% of the data have a value for pace, and it gives me some details about the specific variable. So for example, character min means that the shortest name is 3 characters while the longest name is 22 characters. It gives me the number of unique values, so I have 17,884 unique short names for the players. And for the numerical variables, it gives me the 7-point summary, which is the mean, the standard deviation, the minimum value, which is the percentile 0, the 25th percentile, the 50th percentile, the 75th percentile, and the 100th percentile, which is the max. And it gives me a histogram, a very small histogram of how the variable distribution looks like. So as you see, this answers already many of the questions we had in our aims of the exploratory data analysis just with SCIM-R. So SCIM is this just with SCIM under the SCIM-R library, which is designed for exploratory data analysis. Now let's look into some of the other things. So let's do a histogram of some of the variables. So let's say we are interested to see the player's age in a histogram. We are wanting to see if we have a normal distribution, we have a specific mean, that everything is symmetric around. So we will do ggplot, we will put the data frame, we will do the mapping. The X here is the age because we are trying to get the count of the number of players for every age category. And we are using geom histogram with 60 bins and with some cosmetics. So let's take a look at that graph. So here we can see that our variable is not very normal. It looks like a bell shape, but it's a little bit skewed to the right. So we have some players that are of older age, while most of the players fall, let's say, around the 20, or maybe this is actually 23 years of age. So we can see that kind of our data falls in a specific mean, and it skews to the right. So we have older player much than we have very young players. So we can see also the height of the players and how it is distributed. And here, in fact, we see more of a bell shape because height is kind of a natural variable. So we see that everyone is around a specific height of a little bit less than 180 centimeters. And some players go very high, which is a very small number of players. And some players are very short, which is a very small number of players. Of course, with these, you can see the distribution, and you can also kind of get a sense of the outliers you might have in your data. So let's say we had a bar that is around 210 or even more. Maybe we want to decide to get rid of that specific observation if we are doing a regression that uses the height variable, just so it doesn't kind of skew our data. Let's do the same for weight and see the weight distribution. Also looks like a normal bell-shaped curve. And we can see that the data set is basically around, let's say, 75 or something like this. So this is kind of how we explore the different variables distribution. Now we're interested to see the correlation between some of the variables. The correlation helps us kind of avoid any future problems like multicollinearity if we are using both variables in a regression model. So I'm using here a core, which is a base R function, and I'm telling it to omit the NAs. Of course, omitting the NAs resulted from skimming the variables. We know that there are NA values. If we didn't put this NA omit, we will get an error in the correlation because a lot of the values will be NA. So what we are doing with these NAs is omitting them. So this is omitting the observations with missing values. So if you remember, it was 2083 observations with missing values. And we are getting rid of the non-numerical variables, which is the short name and the nationality of the player, by selecting all the data frame without the first and the second column. So basically this will generate a correlation matrix. Let's look at it. And in fact, it gives us a matrix of 10 by 10 because of the number of variables we have. We notice that, of course, the diagonal is 1 because the correlation of any vector, any variable with itself is 1. And it gives us the correlation between every variable and the other. Maybe this way is preferred by some, but I like to view it with the core plot, which is a library that we loaded. This helps me visualize it kind of in a colorful way. So now I can understand that, for example, I have some high correlation between height and weight, which is expected. So I might want to decide to get rid of one of these variables or combine them, for example, use the BMI instead by having a function of both of them to capture the information. I can see that, for example, the overall is highly affected by passing. It's somehow affected by dribbling. Basically, it's correlated with many of them. We can see that the shooting is also correlated with dribbling. And we can see also that, for example, height is slightly negatively correlated with pace. So the kind of the brown or the red shades are in the negative side and the blue shades are in the positive side. So this type of information tells me a lot about my variables. Now I can, for example, get rid of some of the variables in my final model and start my primary analysis with a specific subset of the variables. Now let's see how the interquartile range of the different variables is. For this we're using a box plot. So we are using geom box plot. Here we're using MELT. MELT is part of the reshape that we talked about. MELT helps us kind of distribute the data frame in a way that that the different variables can be looked at separately in ggplot. And for x, we are taking the variable itself, and for y, we are taking the value of that variable. This is coming from MELT, because if you remember, we didn't have a column called variable or a column called value, but MELT helps me kind of take the variable and the column name separately into two different variables. So if we look at the box plot over here, we can see that the different covariates have different ranges. So for example, the height is in between the 150 and the 200. The weight is between the 50, let's say, and 120 maybe. So the ranges are different, but most importantly, this also shows me the outliers. So here I can see that in terms of age, I have some observations. This could be one or more if they are plotted above each other. It's most probably one, but still, don't make the assumption until you investigate it more. So one player is above 51, which is very rare. So we might want to get rid of that outlier. And most of the players are between, for example, let's say around the 25 years of age. Now, if I want to actually detect the outliers, so let me try to detect that outlier in age. So I will do a box plot stat. So I will take the box plot statistics for the FIFA 21, and I will take the variable out of them. So now I have a variable that has the information given from the box plot of the age. Now I want to see the index by asking which. So I want to see which is from the age is in out. So this will give me a different vector, and if I look at it, it tells me that observation 240. So as we mentioned, it wasn't one that is outlier. We have a bunch of outliers that are far from the IQR. Basically, the 50% of the data is in the IQR. It's between percentile 25 and percentile 75. If you don't understand this plot, you can go to a video in the channel about specific GG plots. One of them is the box plot. So if we look at the age of these players that are part of this, basically we are selecting from the age variable in the data frame these observations that we have over here. So we can see that one player was 53 in our data set, 42, 43, 43. So these are our outliers that are not falling in the interquartile range. Let's see who are these players by asking the short name of that data frame for these specific observations, and this gives me these names of the players that are of that specific age. Let's do the same with weight. So if I do the box plot statistics for weight and I take which of the FIFA players is in out, and I take there are many players in the out of the range of weight. Let me take the first couple just to see. So if I see their weight 96 and 97, and this tells me that they are of a higher weight than the the average or the range of the players. If I see their names, they are these players with the higher weight than the others. Now let's look at the pairs. The pairs is basically helping us see a scatter plot between the different variables. It's part of the base R function. It works only on numerical variables, so we're getting rid of the short name and the nationality variables. So if we look at pairs, it will take a couple of seconds because it's plotting every vector in our data set against the other. Okay, so R generated the pairs plot over here. We can see that it's a very complex graph because we have 8 variables against 8 variables. But if we zoom into it a little bit to see what it contains. So as we can see here, it generated a very complex plot, but we can get some information from it. So for example, we can see that height and weight are somehow linearly correlated because we can see the distribution is kind of following like an upward trend. We can see, for example, the overall with the others is also going in an upward trend. So basically what you do is this variable over here, if you look at this column, it means that this is the X value and every other variable is the Y value. So for example, overall versus shooting, here overall is the X, shooting is the Y, and we can see this trend. And of course the number of points we have is 18,000 or something like this, so you can see a very congested graph. Another good way to look at the pairs is using GG pairs. It's a little nicer. So I'm using TIFF here to save the outcome as a TIFF file so we can see more of the details. I'm setting the height and width of the file and the units as inch and the resolution. So let's do this. Let's generate the GG pairs. It will take also some time because it's a very complex graph. So it will show us the loading of the completion of the rendering of the graph. So once this is completed, you just type dev off, so it will save the file. Now you will find the file in your working directory, for example. So basically I called it GG pairs, and if you open it, you will have a different type of graph. It will give you the correlation, it will show you the points and how they're distributed. Because of the resolution we set in the TIFF function, you can see it a little more clearly than the previous graph. So this is how GG pairs is different. Here you can see also the distribution of that variable. So if you remember when we plotted the histogram of age, it looked a little bit skewed to the right. The height was a little more like a bell shape, and the weight, and you can see all of them in that one kind of graph. So if we continue with our analysis, let's say we're interested in a specific pair. So we want to see how the player overall performance kind of relates to the age. We can plot with ggplot over here and using geom point as the geometric shape. And we use alpha 0.1, so if you have many values, it will give you the difference in the number of values a little more obviously. So if we do ggplot over here, and we're using geom smooth, so we can see kind of the trend or the relationship and how it is best represented. So here we can see that basically the overall performance versus the age is kind of following this shape. Of course, this could be skewed because of some of the outliers we have over here. We can do a linear in our geom smooth, so we want a linear method, a linear model instead of this shape. But you can see, for example, the scatter plot of the two variables using this scatter plot. You can change this by saying method equal lm, so this will give you a linear line instead of the line we have seen. The same relationship with a linear line instead. So this could not be, may not be the best relationship representing because of this outlier, but if we get rid of this outlier which was skewing the data as we have seen, it could be more of a linear line. Let's say we're interested in weight versus pace. We have an assumption that, for example, the higher weight, the lower the pace. We can do the same. And it tells us, for example, that it removed the 2083 rows with missing values. And we can see here the trend of weight and pace. So for example, the higher the weight, the pace seems to be going lower until a specific point where before that it's kind of plateauing. So you can get some more information about the variables using this type of scatter plot. Now let's look at the QQ plot. So the QQ plots, let's say we have an assumption that age is normal distributed among the players. We know it was a little skewed to the right, but let's say we want to check. So first we will do QQ norm. This will compare the age values to the theoretical values of the normal quantile to quantile plot. So let's do this. Then we will have a line that shows us the actual normal distribution and how it should look like. And this tells us that if this line was a normal distribution, our data is not following a normal distribution. As we see here, it's not following the line. If your data was a normal distribution, it would, most of the points would be actually on the line itself. So for example, if we look at the height, because you remember height was a little more normal distributed than the age, and look at it over here, we will see that the data is falling more on the line itself. So we can claim that an exception of some skewness to in these values, most of the data is following a range that is normal. And we can cut, for example, over here by removing the outliers if we want a perfect normal distribution. Finally, let's get into the sum of the summary statistics. Of course, the scheme gives us these summary statistics, but if we want to get them separately, we will do summary and put the vector name over here. So basically FIFA 21 data frame $age will give us the summary of statistics of that specific variable. So this is the 6-point summary. It gives us the minimum, the maximum, it gives us the mean, the median, and the 25th percentile or the first quartile and the third quartile. You can do the same with height, the same with weight to get more information. So now we are done with our exploratory data analysis for that data set. So as I mentioned, it's not one standard way to do it. You can do different plots, different figures, different numerical summaries, depending on what you want to explore with your data. So tell me in the comments, what experience do you have with exploratory data analysis and what type of plots you may generate for different data sets. If you like the video, please hit the like button, and if you want to develop very quickly in your data analysis skills, make sure to subscribe to the channel, and good luck with your data analysis.